Chapter 7, Review. Test when?
Don't you have to do like the whole science to calculate?
Yeah, I probably should have done the whole side for the calculator. I'll just move my calculator inside the red box. Solve the system graphically around answers to the nearest hundredth. Well, that's not very hard. Solving graphically means we're going to do what?
Draw a graph.
I'm not going to draw a graph.
Oh, calculator.
Oh, that's what I'm going to do. Duh. So we are going to need to enter these in. That went wild. There we go. Somebody's going to have to come up with a bracing system. It's going to make me sick watching this thing bounce around. Whoops. Didn't get out of my exponent, did I?
No, good.
Okay. You're the one.
Okay.
Found it! Come on. Come on. There it is. 3x cubed minus x to the 6. I'm probably going to do a standard set. Might have to adjust it a little bit. So here's our 1 over x. There goes the other one. How many solutions? Looks like we've got 3 solutions, doesn't it? I'm going to find the first one. You guys work on the second 2.
I'll find the far right one.
So as promised, I'll find the first one. Negative 0.74 and negative 1.36.
Don't you draw a graph?
No, we don't have to draw a graph on this. What's the next one? 0.80,
80.
comma
1.26.
1.26 and
1.40.
Oh,
Yeah, you're right.
0.71.
graphically. Write those answers. Number 2. Solve the system by substitution.
So, when it says, it doesn't so much.
This is too much.
Oh, you can't do anything.
No, this one's fun.
You can do anything.
What's that?
It's not.
You can take the square root of.
Yeah, well, you
They're saying solve by substitution. And they even set it up to solve by substitution. We have a value for y. I need to substitute this value for y right there. So 16x squared plus 25 times negative 4/5 x minus 4/5 squared equals 400. So we are going to have to square that lovely binomial right out there. 16x squared plus 25 times. Now squaring this binomial, I would square the first thing, which would be 16/25 x squared. And I would multiply it together times 2. If I multiply it together, that's 16/25 times 2 is 32. 25 x. Then square the last thing plus 16/25 equals 400. Now the nice thing is we need to distribute what number?
25.
A 25. And what happens to every one of those fractions? They were really, really nice. 16x squared plus 16x squared plus 32x plus 16 equals 400.
Oh,
So I'm going to get my, because when I distribute my 25, it cancels out those fractions. So 32x squared plus 32x minus something equals 0.
384.
Minus what? 384. I want to set it equal to 0 so that I can do what now?
You can divide everything by 32.
32? Does
12.
it go into everything?
12.
X squared plus x minus, is it 12 times?
Yep.
So all I need to try to do is factor this lovely little trinomial. How does it factor? Plus 4 minus 3. So what values of x make it equal 0? Negative 4 and 3. Now that means my solution will have a negative 4 comma something and a 3 comma something. So we'll just need to go back and figure out the y that goes with it. And we'll use that nice equation where y equals negative 4/5 times negative 4 minus 4/5. 16/5 minus 4/5 is 12/5. So when we substitute in the negative 4, we got 12/5. When we substitute a 3, y equals negative 4/5 times 3 minus 4/5. Well, that's negative 12/5 minus 4/5 more. Negative 16/5. Despite these fractions, they really set it up so it was easy to do. Negative 16/5. Number 3. Where? So on number 3, they say we are supposed to solve by using elimination. What would you like to eliminate?
Multiply by negative.
Okay, multiply the first one by negative 2. I'll write it right underneath. Negative 4x plus 10y equals negative 12. We'll just add these two together here. Wow, that red is sure bright, isn't it? How many y's? 9y equals negative 9. Y is negative 1. So I know what y is. That's what I did. Let's substitute in the second one. I mean, you put it where you want. 4x minus a negative 1 equals 3. So 4x plus 1 equals 3. So 4x is 2. So x is 1/2. I don't think we've run across pre-calc yet, have we? Number 4. Find the inverse of this matrix 2, 3, 6, 4. Then show how to use matrix multiplication to support your result. All right, so here's the first thing that's maybe a reminder of something newer, at least. In order to find an inverse of a matrix, we'll say this is our matrix A. We have to go 1 divided by the determinant. Remember the determinant? 2 times 4, 8, minus 6 times 3, 18. I don't want to see anybody working on a calculator on this problem. Then we exchange the 2 and 4, and we negate the 6 and 3. So what fraction do we have in front? Negative 1/10 times this matrix. Do you see?
Yep.
So I need to distribute that in. It's really just called scalar multiplication. Negative 4/10, what does that reduce to? Negative 2/5. 3/10, I'm going across. What do we have? 6/10, which is 3/5. And negative 2/10 or negative 1/5. Now that is the inverse. So I'll let you write that down. The second sentence says, then show how to use matrix multiplication to support your result. How do we know that that's the inverse? How does matrix multiplication support it? Say that again.
1, 0, 0, 1.
When I multiply the inverse here that we just found, negative 2/5, 3/10, 3/5. Doesn't look like a negative 2 up there. And negative 1/5 times 2, 3, 6, 4, the original. It will equal, what it will equal? 0. An inverse times a matrix will equal the identity. That's what we showed right there. You just showed it in your
For
work.
identity, the longer than
This, I would need to double check to see if these are only left-hand inverses that we're finding. You can try your multiplication, flip the order on your calculator and see if you get the identity both times, is what you could do. I'm not sure if this is just a left-hand inverse. But a true inverse, you're right. The order doesn't matter. Whichever way I multiply it, it should give me the identity. I'll let you try it here. I'll start copying this, but I'll let you try it. Does it work for anybody? Have you gotten that far yet? It works which way? On the left side or the right side? There you go. That's what an inverse should, is work both ways. You don't have to have this copied down. And here's the reason why. There's really no math to do on this problem. says write the matrix equation
Oh.
as a system of equations. Don't solve. So this really means negative 2x plus 3y plus 5z equals negative 6. That's what they're asking you to do, is just write the equation that this matrix equation stands for. 4x minus 5y. This is hardly worth giving you a point. Minus 2y. X plus 3z equals negative 10. That's what they ask for. Just to remind you that matrix equations are really representative of a system of equations. Did I copy it right? I think so. Oh, Z. Z, Z, Z. That should be a Z right there. ZZ middle. All right. Number 6. Find the row echelon form of the augmented matrix for problem number 5. Oh, they're tricky. Now they're going to make you do some work. So what do they mean when they say augmented matrix? What they mean is you need to include in one matrix all the coefficients and the answers down there. Okay, they say find the row echelon form. Now, who remembers what that means?
It was the 1, 0, 1, 0, 0, 1 thing. Stuff like that.
That's exactly right. What we want to do is end up with 1, and then there'll be a number and a number and a number, 0, 1, a number and a number, 0, 0, 1, and a number. That's what we want to finish up with, because this means Z equals whatever you get. This is row echelon form. It's the same thing as triangular form when you don't have it in a matrix, is what it is. Row echelon form is just the name for triangular form when it's in a matrix. Okay, well, any suggestions of where I might start?
Multiply the first row by 2. Do we have to write down like...
I want you to write down what you're going to do. This is what I'm going to do. I'm just going to switch row 1 with row 3. I have my 1 up there now. They gave me a 1, so I'm going to use it. Now I can use that 1 and start going down. So I'm going to take negative 4 times row 1 and add it to row 2. So my next one, my row 1 is done. So I'll keep copying that several times in this problem. Negative 4 plus 4 is 0. Well, 0 minus 5 is minus 5. Negative 12 minus 2 more. 14, 40 minus 14, 26. Did I do my math all right there? So I've got my 0. What do I go for next? I need to make that negative 5 a 1. How do I make it a 1?
0 by 5.
I'm dividing by negative 5, or multiplying by negative 1/5 is how we write it. So on my next one, row 1 again is done, so I just copy it. Let's see, negative 1/5, that's 0, that's 1, 14 fifths, and negative 26/5. Okay, my first two rows are done. What do I go for now? I want to work on the final row. What am I going to do about that negative 2? I want to make it a 0, right?
Row 1 plus row 3.
There you go. We're going to take 2 times row 1 and add it to row 3. I don't know where you want to write it. I'll just leave it up there, I guess. Now, I'm copying the first 2. We're really not changing anything there. Okay, 2 minus 2, 0. 0 and 3 is 3. 6 and 5 make 11. Negative 20 and negative 6 make negative 26. Now what? Negative 3 row 2, add it to row 3. Negative 3 row 2, add it to row 3, and that will get rid of that 3 right down there. So, I'm going to come up over here. 103 negative 10. I have 0 and 0 is still 0. Negative 3 and 3 is 0. Oh, negative 42/5 plus 55/5 is 7/5. Am I right? Do the math for me. That's a 14 there. Negative 42/5 plus 55/5. Negative 42 and 55. Oh. It wouldn't be 7. It would be what number? 13/5. Let's see. Negative 3 times negative 26. What's that? 78?
Yep.
78/5. Oh my. Minus 1/35 gives me negative 52/5. Negative 52/5. Almost there.
5/13.
Yeah, all I need to do now is go 5/13 times row 3. 0, 3, negative 10, 0. 0, 1. Hey, what's negative 52 divided by 3?
4.
Negative 4. Because my 5's can't, I'm multiplying these together. My 5's cancel, negative 52 over 13. What do they want? Row echelon form? There it is. Now if they ask us to solve, what does this last row mean? Z equals negative 4. And then we could substitute back up. But they didn't ask us to do that. That made us do a little work at least. Number 7. Problem 7 and 8 use Gaussian elimination to solve the system. I'm going to let you, and I'm going to tell you where I'm going to let you use calculators and where I expect you to go by hand. I'm going to let you go to a calculator on this. So let's remind ourselves what we do. So go to a matrix. I'm going to edit my first matrix, and we have a 3 by 3. And we put in our coefficients, 3, 2, -1. Oh, I need an augmented matrix. What does that mean?
3 by 4.
I need a 3 by 4. That's okay. I can go up and fix that. Wow, this is so bright, I can see the little squares. All right, so
I
I
didn't even know there was.
quit out. I didn't either until I got a bright projector. And then I want to go back to our matrix, and what are we trying to do? We're going to go to do some math on it. What are we doing? Row echelon form.
Oh, right.
Row echelon form of that matrix A.
Oh. Okay.
And I'm going to tell it in my math menu to give me fractions in case it needs to.
Yes, it does.
Look at that. 1. Oh, why am I writing this down? You're supposed to write it down. I don't need to write it down. There, I wrote it down. So after you have gotten that written down, now we're trying to solve. What do I do now? Yeah, I know that z equals 1. And then we start substituting back. So that's 1x minus 5/7 times my z equals -47. So all we're doing is taking that last row, which tells us 1z equals 1, or z equals 1, and we'll substitute back in. So x will equal, well, I need to add, since times 1 doesn't change my -5/7, I need to add 5/7. -47 plus 5/7 is? Give me the fraction first. -35/7. And what's -35 divided by 7? -5. So I know what z is. I know what x is. I can come up to the top. Oh, that's y.
Yeah.
My apologies. That is y equals. Now I come to the top. 1x plus 2/3 of y, which is -5, minus 1/3 of z, which is 1, equals -2/3. I have x minus 10/3 minus 1/3 equals -2/3. X minus 11/3 equals -2/3. Add 11/3. Add 11 to -2.
X equals.
Now we get 9/3, which is 3. So my answer is, it's an ordered triple, x, then y, then z. Number 8, I'll let you start putting that in your calculator. We're going to use our calculator for number 8 as well. But you can do it by hand. I mean, don't force me. Don't let me force you to do a calculator. we need to figure out what this means.
Just leave it as Z and then substitute. So,
What does this last row interpret as? 0 equals 0. Is that a true statement? Yeah, it is. It means there are infinitely many solutions to it. So we leave Z as Z. And we start working our way back up. What is Y? 9Z plus 13. Even though we used our calculator, we'll still have to use our brains a little bit here. That's 13. Is that really happening?
Yeah, that's right.
Negative 13Z minus 11. Anybody else get that? So we didn't even end up with any fractions, even though we had all sorts of fractions when we started. You need to make sure you can interpret that reduced echelon form matrix when we get it. Number, where are we? 9? This is kind of a step back. But this is a by hand one. So they're just telling us one row operation. They say take 2 times row 1 and add it to, is that row 3? And add it to row 3. 6 plus 2. Maybe I'll copy the other 2. And 8, negative 4 and 9, 2 and negative 3. Double check my work.
2 times row 1.
2 times row 1 and add it to row 3. 2 times 3 is 6, plus 2 is 8. The only thing that changes is the last row.
Oh, that's row 3.
Plus row 3, not row 2. Plus row 3. Maybe I'll move where I wrote this. That might be a little confusing. So that's just one of the row operations that we had to do many of when we did one of those row echelon forms. Number 10, now read the directions. Write an augmented matrix for the system of equations and use the elementary row operations to obtain the reduced row echelon form. We're going to not obtain the, we didn't even talk about a reduced row echelon form. We're going to obtain the row echelon form, if you want to cross out that word reduced. And I'm going to let you use a calculator. So we'll have at least one good one that you have to do it by hand, but then I'll use a calculator on several of these others. It's 3 by 4 again, isn't it? Make sure you don't enter something wrong is kind of where it goes.
Is that reduced rowers one thing?
It is. We didn't do anything with it. What am I wanting to do? I'm wanting to do some.
Oh, that's cool.
What does it do?
It gives you the answers.
Yeah, I'm going to write this down, then I'll tell you about it. Is right.
But that's it.
I'll ask you a question. What if you were asked to solve one of these and you came up with an answer like this? This is telling us 0 equals 1 can't be done, no solution. Now, they didn't ask us to solve this one, but again, make sure you can interpret this.
Number 11.
Is that the next question?
Yeah.
Number 11. Well, number 11. There we go.
Wait, did I?
Number 11 says, I don't know, did you? Give the number of solutions of the system in problem 10. There's no solution. What if they ask you, give me the number of solutions to the problem 8? Infinitely many. What if they said, give me the number of solutions to the problem 7? 1. That's what you meant. Now, what that RREF does, oh, it won't work on this one.
Will you check your values?
Did I get something wrong?
I'm looking over my values and mine are entered
I
properly.
got that.
I got the same.
I got the two.
Oh, why is it?
You got the same thing I did?
Yeah, big.
Is that negative 4 fifths?
I read the wrong problem.
Second row, that's a 4/3.
I
Look
read
right.
the wrong problem.
Okay, you're not.
Cool, one.
Are we okay, Wyatt?
Yeah, I see what I did.
Okay. All right. So I say on these, really, when you're doing it in a calculator, you just have to be careful that you're not entering something wrong. Number 12. Use inverse matrices to determine the coefficients of the function, and they give us this third-degree function so that the graph contains, and then they give us these 4 points. Ooh, cool. All right, so we are supposed to figure out the coefficients to this function. ax cubed plus bx squared plus cx plus d. And it's supposed to go through a set of points. Let me just start with this first point. And I'll talk you through this first point, and then I'll be quiet, and we'll all keep working. Remember, this is an x and a y. Now I'm going to put equals my -8, so equals the y instead of the order that it has up there. And what do I do with the -2?
Cube.
I substitute it into the x, so I would cube it first, which would be -8a. Square my -2 is a 4 plus 4b. And then a -2 there would be -2c plus d. Because -8 is the y. I put equals -8 instead of -8 equals. And now I'll be quiet, and you will quietly work on these other 3 points. We're doing is we're putting the x value into the x and cubing it, squaring it, then by itself in the d. Then what do I do after I have this nice system set up? We're going to put it into a matrix.
Inverse.
And we're going to, in this case, say we're going to use some inverses. So the first thing I need to do, well, maybe I want to write down a little more. I'm going to write down the matrices here. I have a -8, 4, -2, 1. This is a coefficient matrix. This is not an augmented matrix. Now here's the deal. If this is matrix A, and if I multiply it by its inverse, it gives me the identity, which means I just have A, B, C, D equals, and then I need the inverse here.
Do we?
That's how we're going to get our answer. We're going to multiply by the inverse. That eliminates this. It's like multiplying the 3 times a 1/3. It gives me 1 of these. And whatever I do to the left side, I must do to the right side. And I'll have my answers for A, B, C, D.
Wait, why would you multiply the inverse against that? How does that cancel that out?
So I'm going to get rid of that 3. I'm going to get rid of it by multiplying by its inverse. Now, whatever I do on the left, I have to do on the right side of the equation. So that is now just x equals, look at that, there's my answer. That's what we're doing. It's exactly what we're doing with matrices. So we need to put it into our calculator. Again, I'm going to call this matrix A, and I'm going to call this one matrix B over there. So my answer is going to be found by taking the inverse of matrix A times matrix B. Check. That's what that is. That's not what I wanted. It's 4 by 4, isn't it? inverse of that coefficient matrix, multiplying it times those answers, which I call matrix B. Should have done a fraction. Anybody else get these same values?
Yes.
I'm going to get rid of this, since that's not really part of the problem. So my function, I'm going to write them with fractions. My a is 1/2. 1/2 x cubed plus 2x squared. Oh, does it just, oh, it lists your a, b, c.
Yeah.
All right, well, I'm going to write it out anyway. Let's see, 7/2 x. There's your A, there's your B, there's your C, there's your D. But there is the equation that if you graphed it, would go through all those points. 13. Write the system of equations that arise when finding the partial fraction decomposition of this thing. We don't have to take it all the way to the solution. We'll see what that means here. All right, so partial fraction decomposition means we have to have that denominator all factored. So as we look at that denominator, we can factor out a what first? An x squared. So what is that? X squared plus 2x minus 3? I bet that factors again. X plus 3, x minus 1. There it is. Here's that denominator. Okay. Do you remember that when I had a power there in that x squared, I need to take the x and then the x squared. So what form does the numerator take on each of these? Yeah. A, you can do a sub 1. I'm just going to use the letters. A, B, C, D. I'm going to use A, B, C, D.
Why is there an X?
Because when there's a power, remember, I have to take the first one and then the next power up. If I had x minus 3 cubed, I would have to have an x minus 3, then an x minus 3 squared, then an x minus 3 cubed. When we separate that out. So you'll need to remember that. And that's the case that we had right here. Mason?
Let me have the A, B, C, D instead of one.
It's not done.
We're not done yet, but if my denominator looked like this, let's say my denominator was x squared plus 3. It was a second degree. What would the numerator need to look like then? Ax plus b. You might need to go back and look at that again. That's the form. When I have a second degree denominator like this, I need an ax plus b. Nope, because it's not being squared. It's just to the first power. That's just to the first power. It's not being squared.
Okay. So only if the whole piece is being...
Only if the whole thing is raised to a power. You got it. Now I need to multiply everything by that common denominator. Now we keep going. We haven't gotten to where their answer is yet. I'll explain it when we get there. We're still going. So when I multiply here, well, I know in my first fraction, everything in the denominator all cancels out, and I get my x squared plus 3x plus 1. Now, over here, one of the x's cancels, and the rest is still there. Now, I'm going to refer back to this. I still have an x times all this. That is still there. So if I put it in, my x in, it's going to be x cubed plus 2x squared minus 3x that I have to multiply by that a. So it will be ax cubed plus 2ax squared minus 3ax. This is the biggest one. That first fraction only cancels out one of those x's. So the other x has to be multiplied by those other two binomials, which is really this trinomial. Now when I go to the b, well, x squared gets rid of all the x squared. This means it's really this thing. That x plus 3x minus 1 is that trinomial. So that's what I need to multiply the b by, that trinomial. X squared plus 2bx minus 3b. And then move everything to the left on your paper. Now, when I get to the C1, x plus 3 is gone. I have an x squared that needs distributed there. It's really x cubed minus x squared. It's really x cubed minus x squared. Maybe that would be helpful to write it there. X cubed minus x squared. That's what I have to multiply the c by. So I have plus cx cubed minus cx squared. And then when I get to the x minus 1, well, it's really the x squared times that x plus 3, so x cubed plus 3x squared. X cubed plus 3x squared. That's really what I have to multiply the d by. I'm going to fit it. Plus dx cubed plus 3dx squared. 3d. That's not a 30, that's a 3d down there. So let's get together our x cubed terms. I have an a plus a c plus a d. Those are the x cubed terms. I'm going to get my x squared terms. I have a 2a plus a b minus a c plus a 3d. X squared terms. X terms, negative 3a plus 2b. Oh, that's it for my x terms, isn't it? And constants, are there any left? Minus 3b. Now here is what they mean. Write the equations that arise but don't solve. Here are the equations that arise. This is the answer. A plus C plus D equals what number?
1. 0.
0. Wait, why does it equal 0?
Oh, there's no cube.
There's no cube terms on the left side.
Oh, wow. Yeah, that's true. My concept was
The 2a plus b minus c plus 3d equals 1. That's the x squared coefficient. The negative 3a plus 2b equals 3. That's the x coefficient. And the negative 3b equals 1. Do not solve. That's what they meant there. Go all the way to the equations that arise so that I can get the answers, but you don't need to solve them. Yes, sir.
If you were to solve it, substitute like.
If you were to solve, you'd start substituting. B is a negative 1/3. Then you would start substituting. Yes. Probably. 14. Here's one that they actually want us to do all the work, but they made an easier one. In fact, they even factored it for you. So I know I need a fraction for the x plus 1, and I need a fraction for the x minus 1. And the numerator is just a and b. They're not second degrees, so they're not the ax plus b form. Well, essentially we're clearing the fractions. This is what we're doing here. X plus 1 times x minus 1. So on my left side, all I have is 2. And on the A1, x plus 1 is gone, so what is that, ax minus a? On the b fraction, the x minus 1 is gone, bx plus b. So I'm going to collect together a plus b, that's my x term. Negative a plus b is my constant. So what does a plus b equal? 0. Don't let them fool you twice. 0. What does negative a plus b equal? 2. Now we're going to go ahead and solve this. Well, I can just add them together and my a's eliminate. 2b equals 2. b is 1. And if b is 1, a is what? A is negative 1. And then I can write an answer. A, which is negative 1, over the x plus 1. What was b? A 1? 1 over x minus 1. We decomposed, and it didn't smell at all. 15. This is graph the inequality or system of inequalities. Let's see. We did conic sections a chapter or two back, didn't we?
No, that was college algebra.
Oh, that was college algebra that did conic sections a couple sections back. We did this in algebra 2. We're going to have to do some remembering. So this is part A. This is an ellipse. Remember what ellipses are like? There's a center to the ellipse, and then there is a semi-major axis, which in this case is 4, because 16 is 4 squared. And there's a semi-minor axis, which would be 3 in this case. Now this is long in the x direction because this big number is under the x, so how I drew it was just right. And the center is right at the origin because there's nothing with the x's and y's to move it from the origin. So this graph, and they gave you a graph. Well, I'm not going to waste my time solving for y and then graphing 2 equations. I'm going to do it right here. I go 4 in the x direction. That's the end of my ellipse. Go 4 in the x direction back here. That's the other end of my ellipse. I'm going to go 3 up and 3 down. And I'm going to draw a solid line. Notice it's an inequality. Solid line there.
Okay.
That's not so bad. Now, I'm supposed to have values that are less than. Now, there's 2 regions, inside or outside the ellipse. Where is it going to be less than that graph, that line? Inside is where it's going to be. Now, if we have time, I'll come back and I'll do some calculator work on that, but it's a little more involved during the calculator work on that. Part B. 2x minus 3y less than 6. Y less than, I'm going to rearrange that to negative x squared plus 4. I just like that order better, instead of 4 minus x squared. I'm going to solve this one for y. And don't forget, when you divide by a negative, the direction of your inequality changes. So I took that first inequality, I solved for y, I had to divide by a negative 3, which changed the direction of the inequality. Now that first equation, the one that we had to rearrange, is what shape? That's just a line. Negative 2 is the y-intercept. It is going to be a dash line. 2/3 is the slope, up 2 over 3. So I do have a dashed line on that one. Now we're not done because there's another one to graph, but which side of this line is the shaded side? Above. Y values that are greater. We're going to have to stay above that one. What's the shape of this second one, the negative x squared plus 4? That's a parabola. It's a parabola that opens down and has been moved up 4. The vertex is up 4 right over here, and the thing opens down. This one's solid or dashed. This one's also dashed. Where would be any shading? Y is less than this parabola.
It'd be in that bubble closed off.
Would be inside that parabola as well and above the line. So there's our solution on this one. So we'll do 16, and then if we have time, I'll go back and do some calculator graphing on that other one. So solve the linear programming problem. Maximize c equals 12x plus 5y subject to, and then they give us these equations. What do we have to do?
To the y.
What's the point? And you're right. What's the point in solving for the y?
So you can do that.
Yeah, we need to graph it. So I'm just going to write that first one. Solving for y. Color code them. We need to solve each of them for the first two at least. We need to solve for y. I'm going to go to a calculator to help me graph these. Find my calculator, there it is. I'm not going to worry about graphing the x and y axis. Now, I do want to think about my window just a little bit here. I'm going to do -5 for my x minimum. My x max, I'm not sure how far out it goes. I'm going to try 20. Is it more than 20?
Yeah, 100.
Wow, is it that far out? 100. Now my y max, I know about that because my biggest y-intercept, what's 49 divided by 3?
110.
Yeah.
17.
So, no, 49 divided by 3 is...
You can do it.
49 divided by 3 is what number? Just do it on a calculator.
Just do it 20.
Well, I want to get why are we doing what we're doing.
More than it's 5 and 2.
49 divided by 3?
16 and
50.
All right. That's why we're going to choose a 20 up there. I'm going to graph. Who told me I needed to go to 100?
You can do it 35
Window.
or 4.
We'll try 35. I am supposed to be less than that black equation, so that means I'm below. I am supposed to be less than the blue equation below, and we're supposed to be greater than the x vertical and the y horizontal. So in other words, we're in that little shape. Our shaded region is right in here. What are we interested in using now? What do I do now? I need to use the vertices. How many? There are 4 of them in this case. Now I'm pretty sure that that one is 0, 0. And I'm also pretty sure this one with the black is what?
0, 49.
Let's try that again. It's 0, 8. It's 0, 8. We'll make sure we get it with the right equation. Right down here, I'm going to do that one next on this blue equation. How do I find that? Make it equal to 0. That's where that equation equals 0. I'm going to go ahead and just do it by hand. 0 equals -7/3 x plus 49/3, -7 positive 7/3 x equals 49/3. I'm going to multiply it by 3/7, and the 3's cancel. 49 divided by 7 is 7. X is 7, y is 0. How do I get this one up here? Intersection.
4,7.
4,7? Is that what you got? Okay, we're just finding the intersection of those two lines. Now we had an objective quantity, a cost, or I guess they just said C, 12x plus 5y, that they wanted us to maximize. Substitute them in and see which gives us the biggest answer. I'm pretty sure that the 0, 0 is going to give me a 0 answer. The 0, 8 is going to give me a 40. I'm putting the x and y into this objective quantity. The 7, 0, let's see, 7, 14, 84. And the 4, 7, let's see, 48 plus 35, 83? Almost. No cigar. C equals 84. And they say, where does it occur? At 7, 0. And we made it with 35 seconds to spare.
Go back.
calculator one.
The calculator one? No. That's not really a calculator one. What you have to do is solve for y, and in solving for y, you're going to get y equals plus or minus because it was y squared. You have to enter two different equations.